Hello, chemistry students. This is Nico here, and in this video series, we're going to be looking at Module 2 of Preliminary Chemistry, the Introduction to Quantitative Chemistry. And in our first video today, we're going to be looking at the conservation of mass. In this module, you are going to study chemical reactions and stoichiometry. You're going to study the mole concept. Those two are very much related to each other, and we're going to be moving back and forth between them over our first part of this topic. I'm going to take a look at how we talk about concentration and molarity when you have a material dissolved in a solution. And we're also going to take a look at how moles relates to the gas laws and how the behavior of gases is actually related much more to the space between the particles than the actual particles themselves. All right, let's get on with it. In today's video, we need to make sure we know what we're talking about when we talk about a chemical reaction. You've seen this image before in my class. This is the model of a chemical reaction that a lot of prelim chemistry is based around making sure that you really know this concept. All right, the materials that we bring together, the matter we bring together, we call those reactants. They are brought together. When they're brought together, a few things have to happen. The particles need to collide. They need to collide in the right way with sufficient energy for the reaction to actually take place. They need to meet the activation energy of the reaction. And they also need to be possible to successfully rearrange to form stable products. One of the key points just here is that when we have our reactants collide for our chemical reaction, the bonds that are holding together the atoms of the reactants, they have to break and new bonds have to form the products. All right, so we have bonds breaking and new bonds forming in a chemical reaction. So today we're going to be talking about the law of conservation of mass. Now, this is actually a really old one in terms of chemistry. It's one of the central tenets of chemistry. We cannot create or destroy matter. It came out of France. Antoine Lavoisier established it in 1789. Here's a little blurb by him. I'll just read this out. We may lay it down as an incontestable axiom that in all the operations of art and nature, nothing is created. An equal quantity of matter exists both before and after the experiment. The quality and quantity of the elements remain precisely the same, and nothing takes place beyond changes and modifications in the combination of these elements. Upon this principle, the whole art of performing chemical experiments depends. We must always suppose an exact equality between the elements of the body examined and those of the products of its analysis. That's a fancy way of saying that we can't create or destroy matter. All right, the scientist here, the early scientist, Antoine Lavoisier, he's a really big historical figure in chemistry. All right, and it was from his work that we went from having chemistry be a descriptive, a qualitative science. He did thousands of experiments into the combustion of hydrogen and oxygen. He actually named those two elements, actually. All right, and he established his law of the conservation of mass. He was involved in a lot of things that we take for granted these days. Like he was one of the people who helped make the metric system, for example. Okay. Also, for the history students among you, he did not survive the French Revolution. He was a tax collector and quite unpopular as a result of being a tax collector. Unfortunately, met his end on a guillotine. But that's a discussion for another time. So, in short, what that means is the total mass of the reactants or the starting materials must equal the total mass of the products. All right, let's move to a demonstration where I can actually show you that in action. Okay, so the reaction we are going to look at is potassium iodide reacting with lead nitrate. We'll do that in the third empty beaker just here. Let's see what happens when we add these two chemicals together. Both of these are prepared as an aqueous solution, and the reaction that happens is a double displacement to form a bright yellow precipitate. It's really quite Quite striking how bright it becomes when the lead and the iodine ions combine to form lead iodide. Okay, so the way we're going to do the demonstration is we're going to take a conical flask and a small test tube. We will have each of those chemicals separately, one in the flask, one in the test tube, and we'll insert the test tube into the flask, seal the flask up, weigh it before mixing the two reactants, invert it to mix them, weigh it again. And hopefully, if we do that right, the mass of the reactants before we mix them together and the products that are formed from their reaction, as you've seen with the yellow precipitate, is the same. Just got to concentrate here. All right. Let's get that stopper in and make sure it's nice and tight. Okay, what does that weigh? 108.32 grams. Let's invert it, get our reaction on. Nice and yellow. Let's weigh those products. 108.32 grams. There you have it, people. We have reacted two chemicals together, and in reacting them, we have rearranged matter. We have not created or destroyed any matter. So what that demonstration shows us is that our total mass of our reactants, our lead nitrate and our potassium iodide solution when we start is 108.32 grams. Once we invert that and mix the two and form our product, our lead iodide yellow precipitate, and we weigh it again, it still weighs the same mass. We haven't created or destroyed matter, we've just rearranged it. The total mass of reactants is equal to the total mass of products. That all seems simple enough, all right? But there is a but, okay? The law of conservation of mass is only true in a closed system. And when we talk about open and closed systems, okay, what a closed system is basically think of it as like a container. No matter can enter or leave that system, but energy can be put into the system or taken away from it. And energy in the case of chemistry is usually heat. We can either heat something up or we can cool it down. By contrast, an open system is one where both energy and matter can actually freely enter and leave the system. Likewise, an isolated system is one where neither energy or matter can enter the system. All right, you don't see them too much. Okay, so when we look at chemical reactions, provided they're in a closed system, that's when we can really see that the law of conservation of mass is in effect happening. But there's a lot of misconceptions in chemistry where people think we are creating a new material or we are destroying a material when we do a chemical reaction. But in many cases, what is actually happening is we have a reaction that is occurring in an open system, like a combustion reaction, typically occurring in the open space of a room, and we're producing carbon dioxide and water in many cases, and that is spreading out into the environment of the surrounding room. And what that means is that mass is going to be lost to the surrounding environment. And it will look like we're destroying the material that is actually present in our sample when we are combusting it. But all we're actually doing is redistributing it around the surrounding environment. Okay, so that wraps up our video today. I do hope that was helpful. Let's get on with the lesson, people. All right, bye-bye.